We'll be starting today iteration statements. Okay, so what is iteration? In general, statements are executed sequentially during the execution of a program. There may be a situation when you need to execute a block of code several times. So as you know that normally when we write programs, what happens is when the program runs, uh, the statements are executed sequentially one by one. So if there are 5 statements, statement 1 will be executed, then statement 2 will be executed, then statement 3 will be executed, and so on. But what will happen if, let's suppose, we have a scenario where we want to execute those 5 statements again and again and again? The sequence will be the same, like statement 1 first, statement 2 second, statement 3 third. The sequence will be the same, the sequence of execution will be the same, but we want to run this total execution of those 5 statements again and again. Okay, so that process is called iteration. So programming languages provide various control structures that allow for more complicated execution paths. Okay, so how does a loop look like? A loop statement allows us to execute a statement or a group of statements multiple times. The following diagram illustrates a loop statement. So this is our a sample diagram which indicates how a loop operates. Okay, so this is our starting point. This circular mark, this is our starting point. So the execution, before the execution of the a loop is divided into basically 2 parts. Okay, the loop statement and the loop body. Okay, so there are 2 parts to the loop statement and loop body. So loop statement basically means the condition of the loop. Okay, and loop body means the sequence, those 5 statements or 10 statements or 15 statements which you want to execute again and again and again. So that logic or that portion of the code is called the loop body. You will be writing it inside the loop body. So at the start of the execution of the loop, first the condition is checked. If the condition evaluates to true, by true I mean boolean true. Okay, boolean true and false. So if the condition evaluates to true, okay, then we go to the conditional code, which is the loop body. Okay, it executes, then again comes back to the condition, again the condition is evaluated. If it comes true, again goes to the loop body, executes the conditional code or the loop code, whatever it is there, and then again comes back to the condition. Again the condition is evaluated. If it is true, then again it enters the loop body, and after the loop and the loop body is executed, and again it comes back to the condition. So this process goes on and on till the condition evaluates to true. As soon as the condition evaluates to false, then it signifies the end of the loop. It exits the loop. Okay, the flow of the program exits the loop as soon as the condition is false. Okay, so this part we have to keep it in mind. Loop starts, the condition is evaluated, then the loop body is executed, or the conditional code, which is whatever you can use this term interchangeably. So you can tell it's a loop body, or you can say it's a conditional code, whatever you want. So this code executes, then again comes back to the loop condition, then we evaluated it, then the program is, then the condition is then the condition is evaluated. If it evaluates to true, then again the loop body executes, then again comes back to the condition, again evaluation. If it is true, again goes to the loop body, executes, and so on. As soon as the condition becomes false, then we exit the loop. Okay, so this is how a loop works. Okay, now in Python we have 2 primitive loop commands, while loops and for loops. We mostly use these 2 loops for whatever programming needs we have. Okay, so it is while loop or for loop. So let's see what is actually the while loop. With the while loop, we can execute a set of statements as long as the condition is true. Very important. In a while loop, the condition is supreme. So if the condition evaluates to true, then we can then the loop goes on executing one again and again and again and again. But as soon as the condition evaluates to false, the loop is exited. Okay, so we will take a look at this example in our Visual Studio Code. So let's say I equals to 1. Okay, so while I less than 6, print I. After that, I plus equals to 1. Okay, so this is a sample code that we will be running. Let's see how this code operates. Okay, so we start with I equals to 1, then we go I less than 6. The condition is I less than 6, so the value of I should always be less than 6 for this loop to execute. So now one more thing is, this is the loop condition. Okay, and this part, these two statements, is the loop body. Okay, I repeat again, this part is the loop condition, and these two statements inside, it's called the loop body. Okay, so how many statements can there be in the loop body? 5, 10, 15, 20, 30, 40, 100, as much as statements you want, you can write inside that loop. Okay, so always remember the loop body.
I plus
I plus equal to 1 is basically a shorthand operator. Okay, so normally we want to increase the value of I by 1. So what do we write? I equals to I plus 1. We write normally this one, right? I equal to I plus 1, right? So now let me run this program first. Okay, let me just run this program. So we will get the output. The output is 1, 2, 3, 4, 5. This is my output. Why it is 1, 2, 3, 4, 5? So we have to analyze what is happening inside this program. So we have I equals to 1. Now, as you know, statements always execute sequentially, one by one after another. So first I equal to 1 will be executed. The value of I will be 1. Then this condition will be checked before entering the loop body, before entering this body, so that this condition will be checked in the while loop. I less than 6. Is 1 less than 6? True. Enters the loop body. Print I. The value of I is 1, so 1 will be printed first. After that, I equals to I plus 1. So I's value becomes 2. Right? I equal to I plus 1 means the value of I becomes 2. And is after this statement, is there any other statement to execute? No. Since there is no other statement to execute, the control will return from this line again back to this condition. So the value of I is 2 now. 2 less than 6. Is it true? Yes, it's true. It comes inside, print I. The value of I is printed as 2. And then again it comes to this line, I equal to I plus 1, which means 2 plus 1, 3. The value of I becomes 3. And again it goes back to evaluating this condition. So the value, as you can see, if you see the loop body, we will see that the value of I is being printed one after another, and the value of I is being incremented. So the question is, how long will this loop run? So I less than 6, which means the value of I will reach till 5. After that, whenever I will become 6, this condition will become false and we will exit this loop. Okay, so let's make it more interactive. Let's say I am writing a print statement over here, starting loop. And let's say after this while loop, I will write another print statement, loop has ended. Okay, so these two statements will also be executed, and this will give me a clear view. Now one more thing we will do, that is we will put a breakpoint over here. Okay, a breakpoint. So what is a breakpoint? Basically a breakpoint, this is just advanced stuff. Okay, so a breakpoint basically means we can see how the computer executes the program line by line. Okay, this is out of your syllabus. Obviously it is a much more advanced thing, but I just want to show you using breakpoint we can see how the flow of a program actually runs. Okay, so as soon when you will visualize it, you will be able to understand better. Okay, so let's start. I will just start debugging. Okay, so we will execute the statements one by one. So first we will execute this one, print starting loop. As you can see, computer has printed starting loop. Now where is the this we call as the execution pointer. Execution pointer means that it points to which line will be executed right now. Okay, so I equal to 1, let's execute this line. I equal to 1, you can see in the memory we have a variable I whose value becomes 1. Okay, in the memory we have a variable I whose value becomes 1. Okay, now let's now see the pointer is at while I less than 6. Okay, so let's execute this line. Okay, so I less than 6 evaluates to true. So computer now moves on to the loop body, this the first line of the loop body, which is print I. Let's execute this line and see what happens. See what did we get as output? 1 being printed out in the console. Right, in the console we see a 1 is being printed out. Now the pointer is at which line? I equal to I plus 1. Let's execute this line, and you will see how the pointer again jumps back to this line and it will evaluate the condition. Okay, so let's execute this line. See, as soon as I equal to I plus 1, the value of I over here becomes 2, correct, and the flow of the program has jumped to this line again. Okay, so now I less than 6 will be evaluated. Let's evaluate this. Is it true or false? Yeah, it's true. Goes inside the loop body. Now we will execute this statement, print I, value 2 got printed. Now I equal to I plus 1 we will execute. See, the value of I is 2. We will execute this I equal to I plus 1 statement. The value of I becomes 3 in the memory. Okay, by memory I mean RAM, random access memory. Okay, so in memory the value of I becomes 3. This is how computer keeps a tag on the loop variables or whatever variables you declare throughout the program. Those values get stored in the memory. Okay, so we can see it real time. We can see it in real time how the values operate, how the program operates with these variables. So now again I less than 6. Let's execute this line. Great. So I less than 6, value of I is 3. 3 less than 6, it's true. Goes inside, again print I is there. Let execute this, and we get 3 as the output in the console. Now I equal to I plus 1. Let's execute this one. Value of I becomes 4. Okay, again comes back to the condition I less than 6, true. Let's execute this one. See, print I. Let's execute this one. Again we get 4 as the output. Execute. We get the value of I as 5. Now is 5 less than 6? Yes, it's still less than 6. So the condition will evaluate to true. Comes inside, print I. The value of I is printed as 5. I equal to I plus 1. Execute. Value of I becomes 6. Now I less than 6. Is 6 less than 6? It's false, right? So the moment I execute this line, you will see the flow, the control now moves to the end of the loop, to this statement, because the loop will exit. As soon as the condition is false, the evaluating condition is false, the loop will exit. So execute this statement. So it got out of the loop. Now it has come to this statement, the one that is outside the loop. Okay, print loop has ended. Let me execute this one, and the program has ended, and I get the output, loop has ended. So this is my overall output. Alternatively, some people like I equal to I plus 1, but there is another shorthand operator. Normally you can write this, it's perfectly fine, but there is another shorthand operator, which is I equal to I plus 1 can be written as I plus equals to 1. You can write this also, and if I run the same program again, I will get the same output, which means I plus equal to 1 and I equal to I plus 1 is the same thing. So let me run this program again, this time without debugging. I will just run it normally. So if I run it, see, I get the same output, starting loop 1 2 3 4 5, and loop has ended. So plus equal to is called a shorthand operator. Okay, similarly I equal to I minus 1 can be written as I minus equal to 1. I equal to I into 1 can be written as I into equals to 1. Okay, I equal to I by 1 or I divided by 1 can also be written as I slash equals to 1. So these are all shorthand operators. They make the code shorter. Is there any advantage of using shorthand operators over normal statements? The advantage is the code is shorter, nothing else. So if you write I equal to I plus 1, perfectly fine. If you write shorthand operator I plus equal to 1, perfectly fine. It is up to your choice. So Python, we have seen how the while loop operates, right? Now we will see how the for loop operates. Okay, so what is a for loop and how it is used? A for loop is used for iterating over a sequence, that is either a list, a tuple, a dictionary, a set, or a string. We can also use the for loop for executing a set of statements multiple times using a range object. Okay, so all of this list, tuple, dictionary, set, string, all of them are a sequence. Okay, and for loop only operates on sequences. Whatever can be called a sequence, for loop will operate on that. Okay, even a string is also a sequence, a range object is also a sequence. Okay, so now the question is, what is a range object? How do we use range object in a for loop? How do we use string object? How do we use list, tuple, dictionary and all? So for starters we will use a string object. For starters we will use a string object. Let's take this example live. Okay, so I will just comment out this code and I will just start the code for a for loop. Okay, great. So how do we operate on strings? How does for loop operates on string? As you know, string is also a sequence. So how does for loop operates on strings? For x in, let's say, banana, P-A-N-A-N-A. Okay, enter, print x. Okay, this x is called the loop variable. This x is called the loop variable. Okay, this string is the sequence. As you know, string can be written in double quotes as well as single quotes. So this string is the sequence, this x is the variable. Okay, and if I run this code, what will happen is, every time in every iteration the value of x will be each character of the string. So in the first iteration value of x will be b. In the second iteration value of x will be a. In the next iteration value of x will be n. Again in the next iteration value of x will be a, and so on. So each and every character you will get in each and every iteration of this for loop. Okay, so I will just run this loop without debugging first. Okay, so if I run without debugging, so the program executes straight away and you can see the output as b, then a, then a, then a, b, a, n, then a, and n and a. So each character is getting separated out. Okay, each character I will get in x, and now I am printing x, so the value of x will come on the console. Now let's do one thing, let's debug this program. Let's see how the step by step execution of the program takes place. So I will just start the debugging mode, and okay, so the we have only 2 lines of code in this program, right? So the pointer, the execution pointer starts at the first line. Okay, so let's execute this first line and see what happens in the memory. Execute. See, in the memory there is a variable declared called x, and the value of x is the character b or the string b, whatever you want to say, because Python treats every even a single character as a string. Okay, so the value of x is b. Now I will execute this line, print x. See, the output in the console is b. Okay, now again the control comes back to the first line, which is the for statement. Okay, again I will execute. This time value of x becomes a, which is the character after b. Okay, the value of x becomes a. Now the pointer is at this line, execute, and the value a is printed out in the console, and again the control goes back to the for statement. Okay, so execute, execute, and now you will see the value of x becomes n and n is printed out. Similarly, let's execute one by one. Again, execute, 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 and the final output is b a n a n a. So if you use strings as a sequence for for loop, you will be able to get each and every character easily. Okay, that is how for loop for strings work. Okay, so what about if I introduce a space between this string? Okay, so let me just comment out this first code and I will write a second one, and you are saying, like, let's say we have a space. Does not matter, because space is also a character, right? So at some point the value of x will be a space and it will be printed out. Okay, so let's do one thing. Let's execute this program, run, and you can see the output ban, ban. Then again a space is there, so the space is being printed out over here. It's a blank space, and again then ana. Let's take a third example. I will just comment out these two lines, and let's take a third example. Let's say we don't have a space, we have a semicolon. Let's say a backslash. Let's say an at the rate. So what will happen if I have three special characters? So what will happen? Again, let's run this block of code. Okay, so I will go run without debugging, and you will see the output as this one: semicolon, backslash, at the rate symbol. Everything is everything will be printed out on the console one by one character after another. So this is how, if you introduce even special characters inside a string, ultimately it's a string. Whatever character you insert, ultimately it's a string. So you will be able to get each and every character from that string. Okay. Okay. So we saw that how to use the for loop with string objects. Okay, string being a sequence. So how to use the for loop with a string sequence. So now the next we have is a range object. So let's see how the for loop operates over a range object. Okay, to loop through a set of code a specified number of times, we can use the range function. So the range function returns a range object which is a sequence of numbers. Very important, the range function returns a range object which is basically a sequence of numbers. As you know, string is a sequence, list is a sequence in Python, tuple is a sequence. Similarly, range object is also a sequence, and whatever can be termed as a sequence, we can definitely iterate over it using the for loop. So the syntax of the range function is range, then we have parenthesis open, then we have three parameters which are start, end, and step. There are three parameters, and then we have the parenthesis close. What is the meaning of start, end, and step? So let's see. Start is an integer value. We can provide an integer value as a start value, but if you do not provide anything, the default value is 0. Okay. End also we can provide an integer value, but whatever value you provide, subtract -1 from it, the resultant value that you get is the limit of the range function. Okay, so let's say for example you are providing the end value as 6, so 6 minus 1 is 5. Okay, so the last value that you will get is 5. Step is also an integer value, and if you do not provide anything, then the default value is 1. Okay, now the most important thing is how to move in a particular direction with range. By manipulating the step value, we can move in a particular direction. Yes, the step value is one of the most important things, because if you manipulate the step value, you can definitely move in a forward or backward direction. Okay, so to move to the right, use a positive step value, aka is an abbreviation for also known as. So use positive step value, also known as increment factor. To move to the left, use negative step value, also known as decrement factor. Okay, so either you provide a positive value or you provide a negative step value. Okay, so if you want to move, let's say you have a number line like this, and you want to move to the direction towards the right, which is this direction. To move to the right, we have to provide a positive increment factor. By right, you can also say that the direction towards the east. Okay, so to move over the number line towards the eastern direction or towards the right direction, use a positive increment factor. Now what about moving to the left or the direction towards the west? In that case, you can provide a negative decrement factor like -1, -2. Whatever negative values you provide, it will act as the negative decrement factor, and it will let you move towards the west direction or towards the left over the number line. Okay, we will see this in a couple of examples that will follow. Okay, so let's go for some examples. Let's start with an example for x in, I'm going to use the range function, x in range, print x. Okay, here inside the range I will provide 6. Now if I run this code, what will be my output? My output will be something like 0, 1, 2, 3, 4, 5. Let us see. Here we go, 0, 1, 2, 3, 4, 5. This is my output, right? So why did I get this particular sequence, or why did I get this particular values 0, 1, 2, 3, 4, 5? Basically, we have provided over here a single value, which is 6. If you provide a single value inside a range function, by default Python treats it as the upper bound, okay, or the upper limit, or the end point. Okay, so in this case the end point is 6. Since there is no other value specified, so the starting value, the start point will be 0, because the default value is 0. The default starting point is 0. Again, there is no value specified for step. So the default value, if nothing is provided for steps, the default value is 1 plus 1. Okay, so basically writing this and writing 0, 6, 1 is the same thing. Okay, so if I write this 0 start point as 0, the end point as 6, and the step value as +1, if I run this code, let's see what happens. 0, 1, 2, 3, 4, 5. This is my output. I get the same output as that of the first one. Okay, so if you do not provide any other values apart from a single integer, then Python will treat this as the upper bound or the end point, and it will use the default values for the starting point as well as for the step value. Okay, another thing to note is, whatever value you are providing for the end point or the upper bound, you will only be able to get the values up till that upper point -1. For example, my upper point or upper bound or the end point is 6. Since my end point is 6, I will get 1 less than it. I mean, the last value that I will get, is 1 less than 6, which is 5. So starts from 0 but ends till 5, which is 1 less than the end point. So whenever you are providing the end point, always remember the values that you will get will be excluding the end point. Okay, this is what range does. It gives you a sequence of numbers. Okay, so you might say, okay, let's do one thing. Let's say the range is, let's say 12. So what will I get? Same thing, default starting value is 0, default increment value is 1. So you will get from value 0 till 0, 1, 2, 3, 4 and up till 11 excluding 12. Okay, excluding 12. So here you can see 11, 10, 9 on all these values. Okay, so up till from 0 till 11 we get the values. This is how if you always like, for example, if you have a requirement where you need a sequence of numbers, you can always use this range function. Also, do we have any other customization of the range function? Yes, we do. The range function defaults to 0 as a starting value. However, it is possible to specify the starting value by adding a parameter. For example, we can write the range function as range starting value and ending value. Okay, like for example, if I write over here for x in range 2 comma 7, so the starting value will be 2, but the ending value will be 6 excluding 7. So if I run this program, see 2, 3, 4, 5, 6, this is my output. Okay, so the range, so you saw the first way of writing the range function, which is passing a single value, single upper limit. The second way of writing a range function is you can specify a initial limit and also an upper limit. So it will take the starting value, but always one less than the excluding value, less than the upper limit. Okay, so we get 2 to 6. This is my output. Okay, so another thing, any other customization? Yes, there is a third way of writing the range function, which is this one. The range function defaults to increment the sequence by 1. However, it is possible to specify the increment value by adding a third parameter. So we know that the default increment is by 1, right? But can we customize the increment? Let's say we want to increment it by 2 or by 3 or by 4. Is it possible? Yes, it's possible. So if, for example, you have given the starting value as 2, the ending value as 7, and you know the default increment is by 1. So let me write an increment factor as 2. Okay, so I gave the increment factor as 2. So this time you will see the output has changed. What is the change? Let's see. See the output 2, 4, 6. So the starting value is 2. What is the increment value? 2. So 2 plus 2, 4. The next value is 4. Again plus 2, 6. The next value is 6, excluding the upper limit, which is 7. So we get the output as 2, 4, 6. So if you want to say, sir, if you want to like, can I use increment value as 3? Yes, definitely you can. If I run this time you will get the output 2 and 5, because starts from 2, then plus 3 becomes 5, then plus 3, 8. 8 is not allowed, so only 2 and 5 you will get as output. So this is how you can write range functions. Okay, so we have seen the first way of writing range function is by specifying a single limit, which is the upper limit. The second way of writing a range function is specifying a starting limit and also an end limit. The third way of writing a range function is start limit, end limit, and give a custom increment factor. By default increment is by 1, but if you want you can give a separate or a different increment factor. Okay, so in this following example we will see how to get a sequence of negative numbers, okay, or negative integers. So let's start for x in range function. I am going to print the value of x. Now let's say I provide over here minus 6. I want to get the values 0, minus 1, minus 2, minus 3, minus 4, minus 5. I want to get these values, okay, excluding minus 6. I want to get these values. So how about if I write minus 6 as the end limit or as the end point? Will I get this specific values 0, -1, -2, -3 and so on? No, we won't get these values. For example, if you run this particular code, you see we do not get any output. There is no output. Okay, so why is this? Why don't we get any output? We have to understand. For example, in this following code, we have not specified any start value, right? So the start value is the default value, which is 0. Now we have not provided any step value. The default step value is +1. So 0 plus 1 will give us as 1. Okay, so basically, since we have not provided any step value, the default step value is positive, and the positive step value means you are traveling in the direction towards the east or in the right direction. Okay, but you want to print 0, -1, -3, -4, -5 and so on. So we have to we have to use the negative decrement factor to travel towards the left or to travel towards the western direction, right? So over here, since we are using the default step value, which is +1, so for Python it is the range, the sequence of values will come as 0, 1 and so on, right? So it is trying to travel in the forward direction, but in this case you have provided the end limit as a negative number, which is in the left hand side of the number line. Okay, so this creates a contradiction, and hence you will get no output. So what is the solution then? How can we get the value 0, -1, -2, -3 and so on? So we will make some modifications. For example, we will give the start value as 0, okay, and to travel to the left hand side we have to give a negative decrement factor. Okay, so this one should work, right? Let's see if it works or not. There we get 0, -1, -2, -3, -4, -5, excluding -6, which is the end limit. So this is how you can get a sequence of negative numbers, but keep in mind, if you want to travel to the left side of the number line or towards the western direction along the horizontal axis, then you have to provide a negative decrement factor or a negative step value. You cannot provide a positive step value and expect to go towards the left. Okay, positive values or positive step values are only for traveling to the direction towards the east or towards the right hand side of the number line. Okay, now I will just copy this code and I will just comment it. Okay, let's take another example. I want to print, I have already got 0 to -5 traveling along the western direction or the left hand side. Now let's say I want to print in a descending order. I want to print 6, 5, 4, 3, 2, 1 and so on. Okay, so you can understand the direction. I am trying to print 6, 5, 4, 3, 2, 1. So I am trying to start from 6 and I want to travel towards the left hand side. Okay, so if you want to travel to the left hand side, we have to provide a negative decrement factor. So if you want to print values, or if you want to get a sequence of values in the descending order, you might use something like this. You might write for x in range, let's say I want to print the value of x, and over here I want to start from, let's say, 6 and I want to travel till 0. Okay, now since I am traveling towards the left hand side, I have to provide a negative decrement factor. So now let's run this code. So we get the output 6, 5, 4, 3, 2, 1, okay, which is our desired values. Okay, so you might wonder, how about if you want to travel along the negative side of the number line but in a reverse direction? Let's say I want to get the sequence of values like -6, -5, -4, -3, -2 and so on, which means I am starting from the negative side of the number line, but I am traveling towards the right direction or towards the eastern direction. So in this case, again, to travel to the east or to travel to the right hand side of the number line, you have to provide a positive increment factor. So let's say I will just comment out this example and I will just use the same example and I will do some modification. Let's say I want to start from -6, okay, and I want to print values till let's say -1. So in this case 0 is perfectly fine because I want to get the range till -1 excluding 0, and since I am traveling in the forward in the direction towards the right hand side of the number line, I have to provide a positive increment factor. So let's run this code. Now I get a value -6, -4, -5, -4, -3, -2, -1, right. So it is very important to understand the direction you want to traverse, okay, and the increment or the decrement factor that allows you to travel in that specific direction.